Hi everyone. In today's lesson, we're going to talk about how to solve rational equations. So first, what is a rational equation? A rational equation is an equation in which one or more of the terms are fractions. So equation means equal sign. So up until this point, we haven't really done any problems that had equal signs. We added, we subtracted, without the equal sign, but now we're going to include how to actually solve for x. So here are the steps to solve. If you need them for reference, I'm just going to go through them. So example number 1 says solve for all values of x and be sure to check for extraneous roots or extraneous solutions. So the word extraneous means where the fraction is undefined. And remember, the word undefined means where we set the denominator equal to 0 and solve. So what we could do before we do the problem is find these extraneous solutions first, and then if we get them, just reject them at the end. So the first denominator we have is 3y minus 18. So I'm going to set that 3y minus 18 equal to 0, and I'm going to solve. So I could take out a GCF of 3, and I'm left with, the 3's will cancel, y minus 6. 18 divided by 3 is 6. And then I can do a little t-chart. 3 equals 0, I can reject. And y minus 6 equals 0, I can solve. So we can add 6 on both sides, and we get y equals 6. So if we get y equals 6, that makes the function undefined, and then we would have to reject it. Now let's try the rest of them. So the second denominator is y minus 6. So I'm going to set that equal to 0 and solve. So I could add 6 to both sides, and I get y equals 6 again. So same answer, that's okay. So if I get 6, I have to reject it. And now this third one is just 3. And there's really nothing to solve. So if I tried to solve that, 3 equals 0, there's no x value to solve, so that doesn't really make any sense. So it's really just these values here. So if I get 6, I have to reject it. Fine. So let's now go through the steps. So step 1 says factor any denominators that can be factored. So it appears that this first denominator can be factored, and we kind of did it over here. Didn't I take out a GCF of 3 and I was left with y minus 6? So what that tells me is that this term can be simplified to 3 times y minus 6. I can't factor the middle one, and I definitely can't factor 3. So now the goal is to find a least common denominator or a common denominator for all of the terms. So it looks like this piece has a 3 and a y minus 6. This piece just has a y minus 6, and this piece has a 3. So this is the part where you want to use colors to help you. So see how this has green and this has green? If we wanted to really finish this and make them all the same, the middle one would also need green. So what that means is I need to multiply this middle by 3. And whatever I do to the bottom, I have to do to the top. So now I have a 3 in all 3 pieces. Okay, so now how about I use yellow for y minus 6? So this has yellow and this has yellow. So in order for the denominator to be the same, they all have to have it. So this also needs a y minus 6. Whatever I do to the bottom, I do to the top. So now that I've included this y minus 6, now all of the denominators have a green and a yellow, green and a yellow, green and a yellow. So 3, y minus 6, 3, y minus 6, and so on and so on. So once I've made that common denominator, the rest is actually smooth sailing. We have to cross off that common denominator and then just solve the numerators. So what's great about this is once we make it, we can cross off the denominators and we're going to focus our attention on the numerator. So we're going to solve the numerators now. So 2y plus 1 minus 3 times 5 I can do is 15 equals 1 times anything is just that thing, or y minus 6. You could distribute the 1 if you needed to, and you would still get y minus 6. And now the goal is going to be to solve. So I like to set it equal to 0 and factor. So first things first, let's combine these. So 1 minus 15 is negative 14. And I'm going to set it equal to 0. So I'm going to minus the y on both sides and add the 6. So 2y minus y is 1y. 14, negative 14 plus 6 is negative 8 equals 0. And the only thing that I can factor out here is really just a 1. So I'm left with y minus 8. And if I do a t-chart, 1 equals 0, I get to reject. That doesn't make any sense. Y minus 8 equals 0. I can add 8 to both sides. And I get y equals 8. Now, I get to keep that answer because I did not get 6. So I do not have to reject anything. So 6 would be the only thing to reject, but I don't have to, so that's my final answer. All right, let's try another example. So example number 2. So it does say the same directions that we need to check for those extraneous solutions. So let's go ahead and find those first. So we're going to take each of these denominators and set them equal to 0. So x minus 5 equals 0. Let's solve that. Add 5 to both sides. X equals 5. Then we're going to take the middle denominator of x, and we're going to set that equal to 0. Fine. And then we're going to take this third denominator and set that equal to 0. So here you're thinking I can probably take out a GCF of x, and x followed by the open parenthesis, and we can do our division. So x squared divided by x gives me x. 5x divided by x, the x's will cancel, and I'm left with 5. And I can do a t-chart. X equals 0. And then x minus 5 equals 0. Add 5 to both sides. And I get x equals 5. So it appears that these are my undefined values. So it appears that we are undefined at x equals 5, x equals 0, and 5 and 0 again. So it's okay that we get double, but if I get 0 or 5, I must reject it. So let's now solve the problem. So the first step from the previous page said factor any of the denominators. So I can't factor this one, can't factor this one, but this one I can. And I kind of just did it over here, right? These factors are x times x minus 5. So I'm going to cross this off and write x times x minus 5. So same thing as before. Each of the pieces need to be the same in all of the bottoms. So see how this middle one has an x and then this right one has an x? That tells me that this side also needs an x. Whatever I do to the bottom, I have to do to the top. So now they all have yellow. This one has an x minus 5 and this one has an x minus 5. And it appears that the middle one does not. So this needs an x minus 5. Whatever I do to the bottom, I have to do to the top. So now it's clear that each of the pieces have a yellow and a green, an x and an x minus 5. So now the next step is I can cancel off the common denominator and I can set the numerators equal to each other. So let's write exactly the way that we see it. We have x times x minus 1 minus 1 times x minus 5 equals 20. So the goal is to solve that. So we're going to distribute the x to both pieces, and we're going to distribute the 1 to both pieces. So x times x is x squared. X times negative 1 is negative x. Now careful over here, when you distribute, you're going to distribute with the negative 1. So negative 1 times x is negative 1x. Negative 1 times negative 5 is a positive 5, and we're setting that equal to 20. So now we're just going to combine like terms and set it equal to 0. So these two are my like terms. So x squared minus 2x plus 5 equals 20. And to set it equal to 0, I'm going to subtract 20 on both sides. So I get x squared minus 2x. 5 minus 20 is negative 15 and equals 0. Now to factor a trinomial, we need to use AM. Reason being, leading coefficient is 1. So we need factors that multiply to negative 15 that are going to add to negative 2. So I believe it's going to be 5 and 3, a negative 5 and a positive 3. And we have to set it equal to 0 and do a t-chart to solve. So x minus 5 equals 0 and x plus 3 equals 0. Add 5 to both sides. We get 5. Subtract 3 on both sides. We get negative 3. So let's just take a look at these undefined values. We got 5 and 0. So if I see a 5 or a 0, which I do, I'm supposed to reject it because it's undefined. So we will reject this one. So you're going to have to make sure you cross it off and write the word reject, otherwise you will lose points. And you may box this one as your final answer. All right, that's it for today. If you guys have any questions, now's a good time to write them down and make sure you ask us in class tomorrow. All right, have a good night.